Wonderful. Well, as I say, an official welcome to you all. My name is Liz Woodham. I'm a member of the NRICH team here in Cambridge. And really, I'm going to be passing over very quickly to my colleagues, Claire Metcalfe and Charlie Gilsdale, and they're going to be taking you through this afternoon's webinar. We'd just like to say thank you very much to Trinity College here in Cambridge, who fund these webinars so that they're free to you as participants. The idea of this afternoon is we're going to work on some of the tasks from the current secondary feature. We're going to be inviting you to participate in the mathematics using the chat facility. And so I'm going to, without further ado, hand over to Charlie, I think. Over to you, Charlie.
Thank you, Liz. I think I'm going to share my screen right from the start so that I can talk about what's on the website. Hopefully you can see the home page now.
Yep, that's turned up.
Great. So I imagine many of you will have seen this before, but just for anybody who's new to this, we've got these big buttons here for students and for teachers, and it's secondary teachers who we've invited to this webinar today. So I'm going to click on the secondary teachers button and show you what's on the secondary teachers homepage. We've got secondary curriculum resources, and if we remember, we'll come back to this at the very end of the session. Unfortunately, we often forget, but there is a mapping document where we've mapped our favorite tasks to the curriculum over there. We've also got a section on thinking mathematically, both for teachers and for students. I did things like thinking strategically, working systematically, exploring, conjecturing, generalizing, visualizing, but also the habits of mind, curiosity, being resilient, being resourceful. So we've got tasks there that are tagged under those headings. But the reason for doing the webinar is that every half term we'll be publishing a new feature, and this is what we're going to focus on today. So I'll click on the latest feature, and we've called it Efficient and Elegant Algebra, because Claire and I, who've worked together on the tasks here, want to convince students that actually algebra can come to the rescue and solve problems very neatly and elegantly. So initially, we're going to focus on these first three problems on the list, which are all about exploring four consecutive numbers. So we're not going to look at every single question, but I'm going to choose a few for us to look and think about. And I'm hoping you're going to use the chat facility to share your ideas. So without further ado, I'm just going to enlarge it a little bit. Is that better for seeing it, Claire? Is that clear?
Yeah, that looks good. So I lost the unmute button for a second.
So there are four separate questions in this first problem on starting to explore four consecutive numbers. And we thought that to start with, we'd ask you to have a go at question 1A. So you've got four consecutive numbers, and you know they add up to 130. And the question is, what are the four consecutive numbers? And we're hoping that more than one strategy gets used to solve this problem. So in the chat, perhaps you could not only put the solution about what the four consecutive numbers are, but say something about how you went about solving it. I'll be quiet now and give you a few minutes to think about it and work on it.
Okay, we've got one strategy appearing.
So I've got a question from Melanie. Where does the +6 come from?
There you go, and you've got an answer.
Thank you.
I think we've got a couple of different strategies that are appearing.
So that's really nice. We've got a sort of a numerical understanding that if you divide by 4, you get 4 32.5s. And so then you could be thinking about, oh, 4 32.5s is the same as 2 32s and 2 33s. And then that's the same as 31 plus 32 plus 33 plus 34. So there's a sort of balancing, it's a knowing a little bit about averages, working out where the middle is, and then sharing numbers on either side. So there's a numerical, so none of you, well, I mean, some of you may have done sort of trial and improvement, but this is a slightly more efficient way of going about it. And some of you are using algebra and thinking about n plus 1, n plus 2, n plus 3, and solving it in that way. Brilliant. That's great.
And I think the only thing that hasn't really been mentioned is something like using a bar method, a bar model method, as a pre-algebra type strategy. So that might be quite interesting for perhaps Year 7 students. Can
you just explain a little bit more what you have in mind, Claire?
Yeah, I'm just going to try and I don't think I can draw on your screen unless I just move it across to my other screen. So by that, what I mean, I'm going to try.
Shall I stop sharing so you can share?
No, that's fine. I think I can annotate over the top. So we've got 4 numbers. Is that turning up?
Yes.
And they're each one more than the next one. It's not very neat.
No, that's very clear.
Okay, so here, these ones here, we've got 6 of these. And then we've got 4 bars. So the 4 bars plus these extra 6, I'll put 4 bars plus 6 has to equal 130. And then that could be used as a sort of springboard into the algebra idea.
Yes, that's great. Yes, Joe Bowler talks about multiple representations, so being able to numerically to be able to do it diagrammatically. And the diagrams mirrors the algebra, which is really nice. Okay, let's skip a few questions. And now let's go on to question 3. So the third question asks us to consider the 4 consecutive numbers A, B, C, and D, where A is the smallest and D is the largest, and then asks us to add smallest to largest, and then subtract the sum of the 2 middle ones. So before you do anything, you might want to predict what's going to happen. Once you've predicted, you might want to try any random 4 consecutive numbers. And then in the chat, could you explain what's happened and why it's happened? Again, we'll give you some minutes, a couple of minutes to think about it. So there seems to be lots of agreement that the result's going to be 0. Could you try and justify? Can you try and explain? Are you surprised that it's 0? Why does 0 seem like the expected solution?
Yes, and Louise has just mentioned that you could use the bar method again for this one to show why the difference is 0.
Because you had 1 bar and then a bar plus 3.
Yeah.
As the two extremes, and the middle ones were bar plus 1 and bar plus 2.
That's not a very good drawing, but
no, that's really good.
So I'm trying to add them sort of next to each other to get an idea.
Yes, that's lovely. That's brilliant.
Looks a bit like a pair of worms.
And Melanie
but...
has also shown algebraically that you're going to get a 2n plus 3 and both positive and negative.
Yeah, so that's one of those situations where being really careful with your brackets is very important.
Yes.
To show that they cancel out, which students who aren't so confident of having a negative and a bracket might find quite difficult.
Yes. But that's why I think it's quite nice. First of all, thinking about what you expect to get, then trying a numerical example. So you know that you want to get 0, and then you do the algebra and make it come to 0. You know, you cheat a little bit, you see. So I've got a slightly different explanation. I think of 4 people who are wanting to play tennis together, and one is better than the other, and then another one is better than the other 2, and the other person is better than all 3, and they sort of, and to make the game a fair game, you get the best player and the weakest player to pair up, and then you get the 2 middle players to pair up, and so that they sort of average out, and then it should be a fairly close match. So I've got that kind of sense of why it balances out. Though, of course, what's nice about Claire's bar model and the algebra is that you're making sure that the steps are of equal size, and that's not always possible with tennis players. Okay, so this is the first problem in a set of 3 problems about exploring 4 consecutive numbers, and the follow-up problem is continuing to explore 4 consecutive numbers. So I'm going to click on that, and I'm going to suggest we skip questions 1 and 2, and I'm going to ask you all to choose 4 consecutive numbers, add them up, and in the chat, tell me what your total is. Because the suggestion in question 3 is that when you add 4 consecutive numbers, you're going to get an odd factor. So Melanie's got 10, that's got an odd factor, 2 times 5. So can you just choose, Jennifer's got 14, which is 2 7s, so that's got an odd factor. Margie has got 46, which is 2 23s, so that's got an odd factor. 90 has got an odd factor, 9 10s, 34 is 2 17s, 26 is 2 13s, 86 is 2 43s. So it does look like all the sums that you're getting have got an odd factor.
I think we can put, looking at it, it looks like all the sums we're getting as well are 2 times an odd number. So for all of these, Charlie, you've said it's 2 times 5, it's 2 times 7.
Yes, I didn't get 18, which I was going to say, oh, that's 3 times 6. But of course, 18 is also 2 times 9.
Yeah.
So my question now is, so the first thing, I quite like starting this activity with, well, let's just get some data on the board, just like Claire has put all these numbers up on the board and we've got something to look at. And we can see that all these numbers do have an odd factor. Now, the question is, how do we explain this? Can algebra come to the rescue? Or is there another, so in the chat, can you have a go at explaining why these numbers, why if we carried on adding 4 consecutive numbers, we're always going to end up with an odd factor. Numbers with a total which has got an odd factor. Okay, so Melanie's got a lovely algebraic way of explaining it. If we add the n plus 1, n plus 2, n plus 3, we get 4n plus 6. 4n and 6 have got a common factor of 2. So 4n plus 6 is then twice 2n plus 3. And 2n will be even. And if you add 3 to an even number, you're going to get an odd number. So it'll be 2 times an odd number, which is what Claire was saying, that all the numbers in her list are 2 times an odd number.
I'll see if I can draw my bars down in this corner. We had a different explanation from H code. That was back at 419.
Okay.
Right at the start, who said that you get if you add the first pair, you get an odd plus an even, which is an odd number. If you add the second pair, it's an odd and an even. So if you add them together, you get an odd number. So you end up adding an odd plus an odd, which is even. Now, I'm going to see if I can try and draw these bars.
Wait a minute, Claire.
Yep.
Okay, so this convinces me that the sum is even.
Yep. Which is what we're looking at.
Oh. No, but I want to know why it's got an odd factor, because it's 2 times. Wait a minute.
Oh yes. Why must it have an odd factor? That's a good point.
Actually, H code's explanation might be useful for the next question.
Yes. So drawing the bars, you can sort of rearrange your picture to look something.
Claire's now drawing in the bottom left corner,
Yes.
if you haven't noticed.
So I've moved those ones. Does that picture look fairly reasonably clear, Charlie?
Okay, okay, so you had an n plus 1, n plus 2, n plus 3 all in blue.
Yep.
And then on the bottom row, you've added n to n plus 3, and you've added n plus 1 to n plus 2.
Yep.
So now you have 2 rows, and both rows have got 2 n's plus 3.
Yeah.
So the length or the width is going to be an odd number, because 2n will be even, plus 2 will make it even, plus another 1 will make it odd. And it's 2 times. Brilliant.
Yeah.
Yes.
With some students, you may need to talk about why 2n plus 3 is odd. But again, you can do that with another bar model.
But you might say it's 2n plus 2, which is
1.
even, and then plus 1. Great. Okay, I think all that might help for question 4. Again, can we have a go? Oh, well, we've got lots of numbers already. We've already added a plus b plus c plus d, and it tells us that it's never a multiple of 4. So can we look at the numbers that Claire wrote? 10, 14, 46, 54, 90, 34. 26, 86, and 50. They're all even, but none of them are multiples of 4. Again, can you use a chat to explain?
So if you use the chat to explain why you think it can't be a multiple of 4, and whilst you're having to think about that, we'll just address H code's concern. So having an odd factor means you can divide it by an odd number. So 10 has got a factor of 5. I can divide it by 5. 14's got a factor of 7, and so on. There's some really nice explanations coming in. Well, I like Juliet's. That's probably what I would do.
Yes, I really like the diversity. It would be quite nice for children to see that having (4n + 4 + 2) or 4 times n + 1 + 2, they're all different ways of expressing the same thing, but they all tell the same story. Brilliant. Yes. So it's really nice the way that. Oh, sorry.
It will have lost the annotations.
I'm really sorry, Claire.
It doesn't matter. It doesn't matter. If you could tell me what you want back, I can put something back.
Okay.
So you were talking about the different ways of explaining it.
Yes. Okay. I mean, I'm not sure there's very much. I think questions 3 and question 4 go really nicely together. We're using the 4n + 6 idea in different ways. And
then question 5 is quite similar as well.
Yes.
Because it's still concerning the 4 numbers added together.
Okay. So which consecutive numbers are such that a + b + c + d divides exactly by 3? And again, you might want to just try this numerically initially and see what you find. So before jumping into the algebra, I think when I was at school, we did algebra and it was in a vacuum, no context to it.
But one of the nice things about these 3 problems is that you might have started with question 3 and thinking about it, and then got some algebra eventually. And then having done that stage, can you now skip some stages and use the algebra you've already done to answer question 5?
And actually, you're right, Claire, because we could do the algebra first this time and then check it numerically.
Yeah.
Okay, let's have a go at that. So can you anticipate, and again, use the chat, please. Can you anticipate, can you use algebra to predict what the answer is going to be to question 5, and then try it out with some examples? Try an example to test out your prediction. Yeah, you're right, Claire. Having already started using the algebra, you want to use it.
But then testing this is a really good idea. I don't know if we'd rather have an N or an A for our first letter. A is probably better because A is already been given in the question, rather than introducing a new variable.
Okay, but why have you written twice 2n plus 3 rather than 4a plus 6?
No, that feels like the most simple form, but I'll put the other one down as well. So I naturally go for the factorized form if I'm going to write things out.
Okay, but I just think for question 5,
this might, well, but both are equally useful, but this one might be easier to see what's going on.
okay, so I agree with Ambika's point. If the sum is multiple of 3, then it is going to be divisible by 3. So our question is, can you find some examples of 4 consecutive numbers that are divisible by 3? So will 1 plus 2 plus 3 plus 4 be divisible by 3? Will 2 plus 3 plus 4 plus 5 be divisible by 3? Will 3 plus 4 plus 5 plus 6 be divisible by 3? Will 74 plus 75 plus 76 plus 77? How do we know which Juliet's working with negative numbers, as if maths isn't difficult enough already. Oh.
Oh, so it's nice to try some negative examples out.
Absolutely.
Oh, it's nice, nice explanations. And this is a slightly trickier question than the previous two, I think. So Charlie, how would you approach this one?
Okay, are you gonna write for me?
Yeah.
So I would have the 4a plus 6, and then perhaps say, well, that's the same as 3a plus 6 plus another a.
3a plus 6 plus another a. Yeah.
So I've sort of decomposed the 4a. Now I know that 3a plus 6 is going to be a multiple of 3 because it's 3 lots of a plus 2. So I need the a to be a multiple of 3. And I think perhaps Wendy put that in the chat. So if the first number is a multiple of 3, then the sum of the 4 is going to be a multiple of 3. So,
and then taking some of the things that you mentioned earlier, 1 plus 2 plus 3 plus 4 is 10.
Which is not a multiple of 3.
2 plus 3, that is 14, I think.
Yeah.
And then 3 plus 4 plus 5 plus 6 is 18.
And the first number is a multiple of 3. And so, and I sort of, and when you look at that also, if we ignore the first number and we take the other 3 consecutive numbers, well, 3 consecutive numbers always add up to a multiple of 3. So 2 plus 3 plus 4 is the same as 3 3s. It's the same as 3 times the middle number, because so if you have 3 consecutive numbers, it's always going to be 3 times the middle number. So we know that's going to be a multiple of 3. And so if the first one's a multiple of 3, then the rest, the whole total, the total will be. So if my first number is 75, which I know is 3 25s, I know that 75 plus 76 plus 77 plus 78 will be a multiple of 3. Can I go back to question 4, Claire?
Mhm.
Can we just rub out what everything that's on the screen so far? And I would
hang on, let's
suggest
just do that. Yeah.
another way of going about question 4. So when I asked everybody to choose randomly 4 consecutive numbers, and some people chose 1 + 2 + 3 + 4. So could you write that down for me? 1 + 2 + 3 + 4 = 10. Now, that is an even number, which is not a multiple of 4. Now, the next 4 consecutive numbers, if we could write, is going to be 2 + 3 + 4 + 5. Now, I've added 1 to each of the numbers above. I've added 1 to the 1 to make it 2. I've added 1 to the 2 to make it a 3. I've added 1 to the 3 to make it a 4. I've added 1 to the... So
That's a long
the
place.
total is 4 more than it was in the line above. So I'm going to get 14. The next 4 consecutive numbers will add up to 18, and then 22, and then 26. So I can sort of do this as sort of proof by induction, can't I, Claire? That it's worked for the first one, and I could have chosen 0 + 1 + 2 + 3 if I wanted to, or some negative numbers, but I'm going to be going up in 4s. The 4 times table goes up in 4s. So I'm never, given that I didn't hit the 4 times table initially, and I hit I'm never going to hit a multiple of 4. So there's a sort of non-algebraic way of going about explaining what's going on here, which might be quite nice as well. It's a good introduction to what they're going to do when they do proof by induction at 6th form.
Yeah, so nice way of sort of starting to explain that. Okay, should we do some more consecutive numbers?
Yes, please.
Yeah.
This is when it gets really exciting.
Okay.
Okay. I better click on this.
Yes, that would be helpful.
Right here, we thought we'd have a good question 1. So could we, like we've done everywhere on the previous example, can you choose 4 consecutive numbers? And let's have some numerical examples in the chat, just to start with. Square the largest and the smallest, add them together. Square the 2 middle ones, add them together, and then work out the difference between the first sum and the second sum. So a squared plus d squared, take away b squared plus c squared. So initially, let us find out what we get. Can you write down in the chat what your answer is to that?
It's been a long day, so we're not going to judge if you want to use a calculator.
No, of course.
And lots of people have gone for 1, 2, 3, 4.
Oh, yes. If you've gone for that, have another, try something different. Well, there seems to be lots of agreement here. Everyone's getting a difference of 4, which might be slightly unexpected. I'm not sure I don't know. When Claire, when you and I did this the first time, were you expecting it always to be 4? Somehow squaring made me think that the difference might depend on the size of the numbers. Okay, now then, like before, can you come up with a justification? Is there a reason why this is always 4? Can algebra come to the rescue? is there a non-algebraic way of showing why this works? Okay. Okay, so Louise was not prompted to write what she did, but thank you, Louise, for suggesting drawing out squares. I'm going to stop sharing this, and instead I'm going to share something I drew earlier. So here we are. So Louise is suggesting that instead of bars, we might just have a go at looking at squares. Okay, so here's my drawing that I prepared earlier in true Blue Peter fashion. Let me just check that this is, okay, here we go. So we have a squared plus d squared, as in, and we're going to subtract b squared plus c squared, where a, b, c, and d are consecutive. So a plus 1 is b, a plus 2 is c, a plus d is a plus 3 is d. Okay, so we've got a square there, and the whole square is d squared. So I'm going to think about d squared. Let me just check that I'm doing this. Oh yes, so I'm going to have a go at shading d squared minus c squared. So I'm going to look at these two together first. And this is d squared, this is c squared. So the difference between d squared and c squared is going to be all this section. So that's the d squared, take away c squared, gives me that difference. Now, when I look, let me get it, see if I can find a different color pen. Okay, I've got a red. Is it sufficiently different? Might be. Okay, now a squared minus b squared is going to be a squared minus b squared. Oh, that's going to be a negative, but I can look at the difference. So the difference between a squared and b squared is this. And so the solution is going to be this minus that bit. So let me go back to purple. So I'm looking at the difference between these two. This bit here is the same as that bit there. And this bit here is the same as this bit here. And so I'm left with 1, 2, 3, 4. I'm left with this here. Maybe I should do this to make it very fun. Okay. I don't know whether there's a better way of dividing this to show that it's 4, but hopefully at least, yeah, I mean, that definitely works. I hope I've shaded the right bits.
That's certainly
that okay?
that's one way of doing it.
Okay. I'll stop sharing.
Okay,
I think we've covered all but one of the questions we were going to do, but I want to leave some time for symmetricality and agile algebra, Claire. So I think we'll perhaps stop and let you talk about those two problems.
So the only other thing just to mention on this one, which is there more to discover about four consecutive numbers, is right at the end, we have something which involves trying to find the square root of a quartic expression. There is a little video in the getting started which shows how you might do that. So possibly for some of your year 7s, not year 7s, sorry, year 11s, who are quite confident with multiplying out algebraic expressions, they might like to have a go at that bit and try and factorize a quartic. So you can sort of use a multiplication table backwards in order to do it. Okay, so as Charlie said, we were going to look a bit at a couple more questions. We're not going to ask you to do much more yourself now, but we'll start by looking at symmetricality. So the idea behind this, actually I've already got it, is there. I'm going to make it a little bit bigger. So the idea behind this problem is that it's a set of equations. It's a set of simultaneous equations which you can solve by doing the standard trying to eliminate things, but actually that's not going to be the most efficient route to it. I haven't tried doing this. I think it's going to get horribly messy. So just ask you, actually this question gives you a hint for what you might do. And it says, what do you notice when you add the 5 equations? So just give sort of 30 seconds in the chat. What do you notice if you add those 5 equations? Someone's written 3, but I'm not quite sure what that means. So in a way, adding equations, it feels like you're making the problem more complicated. Oh, thank you. That makes more sense. It feels like you're making the problem more complicated because instead of having 4 unknowns, you're going to get 5 unknowns. And as Melanie said, if you add together all 5 of these, you're going to get 4 lots of A plus 4 lots of B plus 4 lots of C plus 4 lots of D plus 4 lots of E equals 12. And as Hcode has said, you can then divide by 4 and get this. That might be better. Okay, can you use that to work out what's probably easiest? What's the value of E? So I think E is probably the easiest thing to work out. Got one person saying 3. Can you say why it's 3? Again, this is where it gets a bit hard to using that equation. Yep. And we know that A plus C plus D equals 0. Yep. So we know that this lot, is 0. So therefore E equals 3. One of the other things you can do with this problem is you can get your students used to the idea of labeling their equations. Because you might then like to do, let's call that equation 6. You might like to do equation 6, subtract equation 1, and write down what that gives you. That just makes things a little bit easier.
Claire,
yeah.
I mean, one of the reasons I like this equation is you can sort of do it all in your head, can't you?
Yes.
You know that everything adds up to 3. So the top line adds up to 4. So the missing letter A is -1. The second line all adds up to 5. So the missing letter B must be -2. In the third row, they all add up to 1. So there's a 2 missing, and we figure out which letter is. So what I like about this, and about the rest of the questions in this problem, we can sort of do them all in our head, can't we?
We can, but when we're asking teachers to explain what they're doing.
Oh yeah. But I mean, it's a lovely. It's slightly surprising, isn't it, that something that might terrify some children it can be done so neatly.
And once they've had a look at the first one, the second question uses some similar ideas. But I need the mouse, so I can't scroll down. Again, it's giving you a bit of a hint. What you notice is when you multiply the three equations, and then students can have a go at that. There's actually more than one answer in this case, because if you've got something squared, you can have plus or minus the answer. But it's just getting the idea that rather than trying to use the standard methods of elimination or substitution, you can take your equations, make something that looks like it's more complicated, but actually you get something that's easier. So Charlie, what would you do with this one?
Yes, I would multiply everything.
Which is a good idea. Yeah.
X squared, Y squared, Z squared equals 36. So X, Y, Z is going to be either 6 or -6. So if X, Y is 1, then Z can either be 6 or -6. And if Z is 6, then Y is going to be 6 divided by 4 and
I think 4 divided by 6.
Sorry, yes, 4 divided by 6. And of course, if Z is -6, then Y is going to be -4 divided by 6. Or 4 divided by negative, yeah. So I'm going to end up with 2 sets of values. In one case, they're all positive. In one case, they're all negative. The X is going to be.
Oh, let's not worry about writing that down.
1.5, yes, or -1.5.
And then we have a third set of equations, which is very similar to the second set, apart from there's just a few more variables in there. The other we've got 8 minutes. The other question that I want to just talk about very quickly is called Agile Algebra. So we've got a few more questions which that all talking about algebra. Agile Algebra, again, this is the idea, it's slightly different to the last one. It's not about making things look more complicated in order to make them easier. This is a question which is all about, is there any symmetry that we can exploit to make things easier? So we've said aged 16 to 18. There's no reason why some of your year 11s can have a go at it, especially this first question. And we start off by talking about a quadratic equation. And we ask students first to expand their brackets and solve the resulting quadratic, which is fine. Then we ask them to use the substitution y equals x plus 4. So in the chat, why do you think we've asked them to use the substitution y equals x plus 4? And this is something you'd ask your students as well. So we're taking this equation up here, and we're asking students to use the substitution y equals x plus 4. So what is the symmetry that we are exploiting there? Not sure we could use difference of 2 squares at this point, because we've actually got a sum of 2 squares, which is a bit trickier to deal with. But so we've got a couple of people saying that the x plus 4 has appeared in the middle of x plus 5 and x plus 3, which means if we do our substitution, x plus 5 is the same as y plus 1. and x plus 3 is the same as y minus 1. And if you take that equation and you expand it, the y terms cancel out. So you just end up with y squared equals something, which is slightly easier to solve. So that's a quadratic that we could solve using standard methods fairly easily. Using the substitution makes it very slightly easier, but you've still got.
Have we lost you, Claire? I think we
go back at the end and get your solutions in terms of x.
Claire, I think we might have lost you for a
students-
few seconds.
Okay. Oh yes, it just said my internet connection is unstable. Can you hear me now?
Yes.
Yeah.
I think we might have lost Claire again.
I think we have lost Claire again, Charlie.
Yes.
Would you would you like
So
to?
after having a go at the quadratic equation, students can have a go at
Oh my goodness. She's not even
Claire's disappeared.
She's not sitting on her chair anymore. This is.
Oh.
Can anyone hear me yet?
We can now, yes. We were very worried because not only did your internet connection disappear, but you also disappeared.
I wonder, Charlie, whether it might be better. Would you like to wrap up anything else?
Okay. I want to see with Claire. Can Claire stop sharing her screen? Can I share my screen? Oh yes, I think I can share my screen. Okay. Okay.
Okay. Yeah.
Claire. Okay, can you see my screen, Liz?
Yes, I can.
Good. Okay, so just to remind everybody how to find these problems, I'm going to go back to the secondary teachers homepage. And it was the latest feature that we'd been talking about. And there are the 10 problems. We've talked about 5 of them. The 3 to do with consecutive numbers, and then symmetricality and agile algebra. They all say live next to them, which means that they're all open for solutions. And it means that students can send in solutions, and we've got a deadline. On Monday, the 11th of July, they will stop being live, and we will start looking at the solutions that have been sent, and then they'll be published a week or so later. So do encourage your students to have a go at these problems and send us the solutions. You'll see that if you go to any of the problems, it says submit a solution. If you click on that button, your students can send in details. And if you want to know a little bit about what we're looking out for, there is an article that we've written sort of outlining what it is that we're looking for. Now, the other thing that I promised to mention just in the last couple of minutes is that in the secondary curriculum page, here we are, we've got resources organized by topics, and we've got a mapping document here. And the mapping document, I should have opened it earlier, lists our favorite problems, sort of year 7, year 8, year 9, year 10, year 11 columns, and different topics. So I'm looking at the number sheet at present, but we also have a geometry page as well, where there are problems on angles and reasoning, problems on construction, perimeter area and volume, 3D, and then there's a statistics and probability section. Okay, and that appears in the secondary curriculum page. So for those of you who don't know about that page, that's where a lot of teachers are going, and they're mapping some of these problems onto their own school curriculum. Okay, so I think I'm going to stop sharing. Thank you all for taking part, and then return to Liz, who normally tells you about all the things I've forgotten to tell you about.
Thank you
You're
very
muted,
much, Charlie.
Liz.
Thank you very much. And let me share my screen just to, I mean, Charlie has covered most of the things that I would like to remind you about, but just as a quick further reminder, I'm hoping you can see my slide there, which has got our Twitter handle on. If you don't follow us on Twitter, do, and you're a Twitter user, please consider it, because we'll keep you updated on latest events and our latest news that way. Alternatively, or as well, you may like to subscribe to our newsletter, which goes out around about once a half term. Charlie has already alluded to the secondary curriculum page, so I don't need to say any more about that. This link here takes you to all our previously published secondary features. So although today we focused on the efficient and elegant algebra feature, that link there will take you to all the previous ones, many of which we've done webinars on as well. So you can always watch those back. If you are a post-16 teacher, you may well be interested in our STEP resources, which Claire curates for us and coordinates. So do take a look at those. STEP being the examination taken in addition to A-levels for some university entrance for mathematics. The recording of today's event will go up on that page, so do share that with colleagues should you wish, or rewatch if you'd like. And finally, please do give us your feedback about today's event. As I said, this event is free because of Trinity College's generous funding, and it's always good to know how we can make things better for future. In the meantime, we'd like to say thank you very much for joining us. Thank you for your enthusiastic participation as ever on the chat. We hope you have a good rest of your day and look forward to seeing you at a future NRICH event. Thank you very much and good night.
Liz?
Yeah.
I wonder, I know that we've just overrun, but could you just could you share your screen and go to the home page?
Yeah, of course. Yeah.
And just show people how easy it is to find all the pages that you've just been giving us the URL for.
Yes, let me just make sure I'm on the home page, and then I'll share my browser. Share screen, browser window. Okay. Can you see that? Can you see the NRICH, the browser, the NRICH page? Okay. Yes. Yeah. So would you so
the first one that you shared was a secondary curriculum.
Yeah.
So that'll be secondary teachers big button.
Or the blue box, the red box. Yep. So here we are.
And that's a secondary curriculum. And then past secondary features, I think is in the pink.
That's over here on the right hand side.
Yep. And then the STEP link you showed, that'll be in the post 16, up in there in the top, the purple lozenge.
And if we found, perhaps if we search for STEP, here we go, title matches, and STEP advice, STEP mathematics. Oops.
Wasn't it in this post 16 button?
Let me have a look. Ooh, didn't mean to do that. I'm pressing the post 16.
Yeah. And if you go down to be a mathematician.
STEP support. Here we go. Yes.
There's STEP.
That's a much more efficient way of doing it.
Okay. Yeah. And then the last link you showed was the one to do with NRICH Live.
Yes.
Okay.
So that will be where we post the recording of today, and probably There isn't a way to link to that apart from knowing the URL at the moment. However, if you go to our events page and you click on resources from previous NRICH live events and click there, that takes you to all the previous recordings. And as soon as we have the recordings for today's event and tomorrow's primary event up, a link will appear there too. But the sneak preview, which doesn't have any recordings yet, is NRICH-live-June 2022. So it's always of that form. So although there's nothing there yet, of course, that's where the recording will go.
Okay. Sorry to make us all slightly late, but I just thought it was good to see just how easy it is to find
Yes.
these links.
Absolutely.
Okay. And
Thank you
the
very much,
evaluation